Number 5 is the tumbling toast problem, where your toast either falls down on the dry side or the butter side. And in order to test the guy's theory that it's usually butter, we're going to first assume that it's 50-50 and see what kind of variation we get with assuming 50% chance of something happening. And instead of flipping a coin 20 times, I am using the the TI-84 function, random bin, random binary distribution or generator, I should say, 1, 50%, 20 to simulate 20 flips of a coin. And over here in the left-hand corner, I have put down my first 8 results, and I'm just hitting the button. I actually had this, like we did in class, send it to L1 and do a list operation to sum L1, and then I'm converting this to percentage. So I got 11 heads. Now I've gotten 10 heads, so that's 50%. Kind of interesting that with a 50-50 chance, so far only 2 of the 9 have actually been 50%. And then number 10 is 60%. So that was simulated with my calculator. And then we're supposed to make a histogram. So your histogram would have frequency on the y-axis, and then our different values, where we put 50 in the middle here. If you hear anyone whining, that would be my dog Dewey in the background. Dewey, you think I can let you out right now? I'm trying to make a video. Now I haven't left too much room for tails here, and I do go all the way up to 70%. A little bit of an anomaly. And my lowest value was only 45, but I'll put 40 over here. And then what are we talking about here? If I just kind of stacked boxes here, we've got 2 for 50. 45 seems pretty well represented with this high. And then 55 Dewey. I'll let you out in just a minute, buddy. He's not really interested in the math. He's not as interested as you are. We've got a 60, we've got a 65, and we've got a 70. That's pretty uniformly distributed. And the question in the B is the center of this distribution close to 50%? And what would you say? We've got 10 iterations here, and 3 of them were 45, and 2 of them were 50, and so that represents 5. And then the other 5 were actually above 50. But that means that our median really is 52.5, or between 50 and 55. So we've got 5 above 50 and 5 below or at 50. So for part C, it says to pool your resources, and since we're not in class, I went ahead and did 100 repetitions and stacked my little dot plot here. But now I will make this into a histogram, and it's not perfect. 100 reps is not going to be law of large numbers, making this all perfectly bell-shaped. For some reason, 10 heads out of 20 did not come up as frequently as 9 or 11. So really 55% wins here. The 50% is a little bit short here that I'm drawing right now. And there's the king, 55. But would you say that this is centered on 50%? And I tried to count my little dots. They look like stacks of Cheerios here. I think I have 100 repetitions. So certainly we have a symmetrical shape, just a little lumpy, but no gaps. And like I said, this 50 is a little bit shorter than you would expect. But there's 100 repetitions. So question 5C asks, how much variability is present? I'm sorry, that's letter D. Letter D asks, how much sampling variability is present? And, you know, if let's see, can I change colors here? I don't think I can. If the center is really right here, well, we have a lot of variability, don't we? And I put this into my calculator. Turns out I have 101 values, but I put each value here into list 1, and then I put the frequencies, you know, 3 and 5 and 10 or whatever this is, and had it calculate a mean for me. And here we're going to call this sample proportion. Well, our sampling proportion actually averages out here to 0.519. So we know that the population proportion down here is actually, P is actually 0.50, but with all our 100 repetitions, we get a sample proportion of 0.519. That's the average across 100 repetitions, but each time, sometimes our sampling proportion was actually, you know, out of 20 flips, we had a 30 or 35. We had a 70 or 75. So the range going from 75 to 30, we have a range of 45%, and it gave us a sampling standard deviation of basically 0.1, so 10%. So what does that mean? At least if you go 2 standard deviations to the left, that's 20% to the left, and sure enough, between 30 and 50 captures some or all of what we had under 50%, and then you have 2 standard deviations to the right. So 4 sigmas pretty accurately gives us our range. So to answer that question, there's a lot of variability. We have a center of just about 50 or 51%, but on any given sample, we're bouncing a little bit to the left or a little bit to the right because of random variation. Letter E says, why do you think Mr. Matthews is asking so many students to participate in this experiment? And that is the magic of sample size. So as you get more and more people involved, and what are they doing? I believe they're each taking the tumbling toast challenge and recording whether they fall butter side or not. And the larger sample size you have, the more you are to hit this target right here. Now, if truly it isn't 50%, then it'll target some true mean, and I believe that he is saying that the butter side was more likely to be over here, so whatever the true mean is, that large sample size will hit your mean. And that is the tumbling toast.